You mentioned the cold temperature of the mirror, and then obviously there's this dust problem. Are there what are kind of the top challenges that you faced in designing the instrument and or experiments that you would not normally face on Earth?
Yeah, so a space instrument has to be small and compact and lightweight, and it has to be rugged. And so those are some of the things that we don't necessarily think about for laboratory work. So I'll start with those and just say, look, we have to make them lightweight and small. Those things are fairly obvious. But then there's a lot of other things that maybe are a little bit less obvious, and that is this kind of pragmatism that I mentioned already, that you don't have anybody there to blow or brush the dust off of your samples. You have to do everything robotically. So things that you would think about doing, you try it once and you move something out of the way and try it a different way. That all takes a lot more time doing that remotely on Mars. Maybe I should just step back and explain a little bit. We don't joystick anything on Mars because it takes up to 40 minutes to get back any information that we send to the rover, given how far away it is. On the moon, it's actually a little different. And so for that reason, we send up each day a whole set of commands for everything the rover will be doing that day. Driving, using its arm, using the cameras, using any other sensors. And so that all has to get packed together into one long set of sequences that'll take all day. And so because of that, we really have to do things in a way that is well scripted, well understood. We need to know the coordinates where we're going to be pointing and not miss the first time. So various things like that. And it just makes for, that's how everything is done, basically robotically.
So the automation has to occur. Now, is that augmented in any way with artificial intelligence or machine learning to maybe allow you to go back and try again? Or if you're doing experiment A and then it's supposed to be the next step, but the wheel isn't in the right place or something, are there learning approaches or other things that are helping that? Or is it just really reading the code and sort of mindlessly executing it?
Yes, Adam, there is automation that is built into some of this. I already mentioned the fault protection so we don't shoot the rover itself. There's another thing that we've used fairly extensively on Curiosity, and we'll be getting going sometime in the not too distant future on Perseverance, and that is some sample selection intelligence. And so JPL actually developed a software algorithm that's called Aegis, and I don't know if I know what the acronym stands for every letter here, but it starts with automated, and it's for increased science is the last two at the end, but it is really to take the images that the rover takes and pick targets for SuperCam out of those images without ground in the loop. Because if you think about how we operate this rover, it has to do its full day of operations, and then towards the end of the day, it gets its antenna in sync with a satellite that's passing overhead, sends up the data to that satellite, which then goes back down to Earth. And then we have to look at things to pick a new target wherever that rover is out of the pictures we see after it's finished its drive. And then we can get commands up to do the next targets, and then it's another day before we get that data down. If we can cut that extra day out of there, if the rover can drive to a new spot, take pictures, and already start taking spectra of interesting places on there, we save a whole day in that whole loop. And so this Aegis software will do just that. It'll pick a target out of these images, and so we give it some intelligence. Basically to find a rock or to find a vein or some other feature, and then it will find those things, take the spectra for us, and send the data back a day ahead of time. And so that's really useful, and this rover is, I think, going to get more into that as we go along. I mean, this is the 21st century. We're in, and it's going to be the century of smart technology, and that's going to apply for spacecraft on Mars as well as anywhere here on Earth.
Oh, that's neat. So it really is, if you will, Industry 4.0, but up on Mars.
Yes.
Yeah.